Okay, so the topics today, we'll go over our homework that was on charts, graphs, exponents, and radicals. Then we'll look at some more radicals and exponents. Hello, Michelle. Alba's on. You on? Michelle, you on? You on mute? You on mute? Michelle, you on mute? Unmute yourself. Hello, Maureen. Okay, so we will look at.
Can you hear me?
Now I can hear you, yes.
My mom is coming on in a second.
Okay, well, we're just getting started. We'll do our homework, then we'll look at some graphs, charts, and radicals and exponents. Okay, so let me bring up the homework. Let's see, where is my homework? Having a problem again with my sharing. Okay. Trying to bring up the homework.
Oh boy.
Can you see the homework?
It's not yet. That's the topic.
Yes, no?
No, that's the topic.
What the topic?
Okay, let me,
Hi, Bertie.
How you doing?
can you see it now?
Yeah.
Okay, you see the bar graph. Okay. All right, so this is our homework that was on graphs, charts, exponents, and radicals. Now, the first one, and thanks to you who sent in the homework, I corrected it and sent it back. Email. Did everyone get their email back?
I didn't get a look like I was sleeping.
Oh, okay. Well, I corrected it and sent it back. Okay,
Oh.
let's look at the first one. That's a bar graph. And
Before
what
you
is,
continue, Ms. Barbara, I wasn't quite sure how to do the answer for this bar graph. I wasn't sure. So
okay, well, let me just say something about bar graphs. When you're looking at any graphs, you want to look at the subject of the graph and what is being plotted. So for this graph, it represents scores on a scat math test.
yeah.
All right.
Yeah,
And
right.
so on this is the y axis right here. Those are
Okay.
scores. On the x, you have ranges of the score. That actually, this is the number of students in the school that
Oh,
took the test. And it shows where they fall in terms of the range of the SCAT scores, which is on this X. See, so these represent ranges of SCAT scores. That's on the Y. The
So,
X, go
okay.
ahead, Mercedes.
So this step like going up are those are the scores.
The numbers you see at the top of the bar represent the number of students that fell within the range below it.
Oh Lord, I
You
know
got
now.
it?
I didn't so understand it. But I tried to give an answer. I don't know.
Okay, so Mercedes, the 6 right here represents the number of students that fell within the range 201 to 300. Whereas 40 students were in the range 501 to 600. You got
Oh,
it?
yes, no
Okay.
understood.
So when I sent you the correction back, I made a note of that the top of the bar graph represents the number of students that were in the range below it.
Okay.
And that's right here on the X line. Okay, so 16 students were in the range 601 to 700.
Okay.
You got it?
Yeah.
So these numbers over here represent the number of students. Notice this 40, if you go from this Y line over to the bar, you see that's a 40, right?
Okay, got you.
Okay, and there's the 30, just go from that 30 on the Y line, top of the graph, the bar here is 30, all right?
Yeah.
And then the 18, see that bar is below the 20. So that's an 18. You got it?
Yes.
This one is above, this is, well, it's slightly above the 5, so it's a 6. Whereas the 701 to 800 is the 10. So if you go all the way to the Y line, you see that's a 10.
Okay.
Okay, I want to make sure you can read these bar graphs because bar graphs show you the values above the bar. Okay, each one of these represent a bar. So you've got 6 bars and they're within the 6 ranges.
Okay, can I ask a question?
Yes, question, Mercedes.
The same homework carries about the square root. This homework talk about the square root. A square root is a part of it too.
Yes, yes. We're going in order though.
Okay, no. I'm just wondering if I did the
Yes.
right homework. That's what I'm thinking.
No, we had exponents and radicals on this homework along with the graphs.
Okay.
All right.
I don't know if I did the right homework. I'm asking the question.
Yeah, let me just okay. So the homework had from 1 through 5 was graphs, and then 6, 7, 8, 9, 10, and 11 were exponents and radicals. All right.
Okay.
Okay. So now the first question here asks, Maureen, are you there?
Yes, Miss Barbara.
Okay, read question number 1, Maureen.
Miss, your picture black out some of the reading.
How many students at Fort Middle School score higher than 600 on the math portion of the
It's all it's a little bit, Maureen. 1 minute. Can you come go down a little bit? Yes, that's it, miss.
Okay.
That's it. Too far down.
Okay.
You're going too far down.
Going too far. That's it.
Can you see it now?
Yeah, just go a little bit to my left. That's easier, right? You see all the readings.
Okay, I just want to make sure you can see what Maureen is reading. Okay, Maureen, read number 1.
And up back to the same place.
How many students at Fort Middle School score higher than 600 on the math portion of the SCAT?
Yes. How many students at this middle school scored higher than 600? Now, Mercedes, you see the ranges of the scat here, right?
Yes.
So it said higher than 600. That means there are only two bars higher than 600. This bar and this bar. And what do they add up to?
800.
No. The number.
Good afternoon.
Hello, Alva.
Sorry to be late. I was trying to see if I could get my laptop to use.
Okay, so you're on your phone? Are you on your phone,
didn't get-
Alva?
No, I'm on the computer at home, but I had the laptop outside. Was
Oh,
trying.
okay,
Yes.
so you're on your computer. All right.
Yes,
now-
Miss Bob.
Okay, now, Alva, did you hear what I said about the bar graphs?
No, I was just coming in from outside.
Okay, okay. Maureen, you want to explain to Alva what we just said about the bar graph?
Not really, Barbara. I really don't I don't even understand them sometimes myself.
Okay, Mercedes, you want to explain what I just said about the bar graph? This bar graph.
Okay, you were saying that okay. From the top across from 40, right across the
No, start at the beginning. What is the subject of this bar graph?
the subject of the bar graph says score on the scan,
Scat.
math,
Scat.
yes, thank you, scat, math portion, what is it, Paul, middle
Polk Middle School.
6th grade student.
So Alva, that's what you want to look at first, the subject. So the subject says scores on the scat math portion for a middle school 6th grade students, right? So that means this bar graph will be showing you scores.
Yes.
Okay. Now, not only will it be showing you the scores, it will be showing you the number of students that had these scores within these scat ranges. So Mercedes, what is on the X line? What do you see on the X line? What do you call that in words?
Not numbers ranging from 0 to 45.
No. This is the X line
Okay.
right here. What do you see on the X line?
We are seeing numbers 201 to
No, I don't want to hear numbers. I want to hear words. What are these? What are these
Letters.
right here? They're not letters. What are
Oh,
they?
those
The
are
student-
numbers.
Oh, they're blocks.
Those
Isn't
are
there-
numbers. The
No,
score
you see my cursor? I'm going here.
Oh,
Yeah.
okay.
What are
That's
these
right.
numbers? What do you call these numbers? 301 to 400, 601 to 700. What do they represent, Mouse
The
ladies?
scores are from the children math exam.
No,
They represent the students.
no. They represent ranges
Okay,
Ranges.
on the scat. These are ranges. 201 to 300, that's a range. 501 to 600 is a range. 701 to 800 is a range. So
I was saying this heights.
no. These are ranges of scat scores.
because
I
you
like
have a
those.
low and high number in each of them.
Yes, because they are ranges. 201 to
Okay.
300, low
And low.
201 to high 300. This
Yes.
one 401 to 500, low 401, high 500. Okay, now Maureen, these
Yeah.
numbers over here on the Y line, what do they represent?
The students.
Yes, the number of students that fell within the various ranges. All right. So these numbers represent number of students These numbers on the X line represent SCAT score ranges. The numbers at the top of the bar represent what, Maureen?
The grades,
No, what is these numbers? What is 18 right here? What does that represent?
the amount of children. Hmm,
Mercedes, you remember? What do these numbers represent?
I am on the same word that she says. I think it was a number of students.
There's the number of students that scored within the
Okay.
range below it.
Oh, I see, okay.
Be complete now. 18 students scored within the range
Range.
301 to 400.
Yes.
Alva, you get that?
Yes, Miss Barbara.
Now,
I
let
do.
me ask you a question, Alva, since you told me you get that, right?
Yes.
How many students scored between 501 and 600?
Okay, 501. and
Ranges are right here
600.
on the X line. How many students scored between 501 and 600?
I would say 16, no?
No. Here's the range right here, Alba.
Yes,
What number do you see at the top of that bar? This bar right here.
40.
That's right. That's the number of students that scored within this range. You see that 40?
Okay,
if
I
you-
understand now.
Yes, if you
Click,
take that
yes.
40 all the way to the Y line, you see the 40, right?
Yes,
That
yes.
40 matches up. Now,
Yes.
how many students scored between 701 and 800, Alba?
701 and 800. It's
Right here.
yes.
How
and
many students scored within that range?
it is okay. Is it 5?
No, read off the number at the top of the bar. What is that number?
10.
10. You just read
Okay.
it off the top, right? 10
Yes.
students scored between 701 and 800. All right.
Okay.
How
yeah.
many students scored between 201 and 300, Alba?
18.
201, yeah, 6, right here.
Yes.
Very
yes.
good.
6.
Between
yes.
201 and the 300 range, you had 6 students.
Yes.
All right. Now, your question was to find how many students scored higher than the 600.
Okay.
Okay, Alva, which bars represent higher than 600?
The bar that represent higher than 600, it's 10. It's 10.
And anything else? Any
10
other
and-
bar greater than 600? Look at your ranges.
The range is 601 to 700.
How many people scored there?
16.
Right, okay. And another number higher than 600, you said was the 701, 800. How many people scored there?
10.
What's the sum of those two numbers?
That's 26.
So your answer is
Okay, so okay, hey.
A.
Yeah, I know I picked 6C because I didn't understand the bar graph.
Right, yeah, you're not the only one did that. That's why I
Yeah.
wanted to go through it to make sure you
I
understand.
do it wrong too, but then I correct it.
Okay. All right, so greater than 600, you see 2 bars represent greater than the 600. 601 to 700, 16 students scored in that range. 10 students scored within the 701 to 800. You add those up, and that's 16 plus 10, and that's how you get 26.
So that's how you do it, miss. I didn't even understand.
That's the question. That's the question,
let me-
and that's the answer.
Let me think. You're saying
Mercedes,
Yeah, can you hear me?
Yes,
Yeah,
Yeah, you're saying that the question is how many students score higher than 600 on the math portion. So from 601 to 600 and to 800, that's how I check it.
that's
Is it
right. Because
yes?
that range, both of these ranges are higher than 600, right?
Okay,
Yes.
You have this bar and this bar.
okay,
So you had both of them and you get the answer.
That's right, Alvin.
Yes, yeah.
oh, okay.
Now, let me ask you a question now. How many
oh,
students scored lower than 401, Alva?
Okay, 401.
How many scored lower than 401?
Okay, you have 18 and 6, that's 24.
That's right. Very good. Lower than
I'm
401.
getting it, Miss
That's
Barbara.
it. Wonderful. Yes, because 401 is this bar. So these two bars, 301 to 400, 201 to 300, and Alva added 18 and 6, 24. Okay. Maureen,
that's it, brother.
how many students scored higher than 500?
I really cannot see this. It's too small.
Okay. Mercedes, how many students scored higher than 500?
Okay, 40. Um, the score below say 51 to 600. So I choose 40.
How many, I ask you again, how many students scored higher than 500?
Okay, let me give an answer. There must be this answer. The answer should be, you say score higher than 500. That is 6, 66.
40 plus 16 is 56, plus 10 is 66. That is correct. You
Thank
had to add this bar total, this bar total, this bar total, because they all are greater than 500.
Okay, gosh, getting it.
You got it?
Yes, thank you.
Okay. Now, Alva, how
Yes,
many students scored lower than 600?
30. uh, 30 and 18, that's 20, 30, 40. Is it 48?
No, actually, you can't answer that. Remember, I said lower than 600. This range goes
lower.
up to 600, right?
Yes, so lower.
Lower.
Okay, it would be 6.
Now, you can't answer it because this has 600 in it. But now, if
Yes.
I ask you how many students scored lower than 501, what would be your answer?
And 501, I would
How
say,
many scored lower than 501? What would be your answer?
I would say 18 and 24.
No.
Lower than lower than
500.
lower than 501.
Okay, so it would be 30.
Lower than 501. It's more than one bar.
500? No,
Lower than 501. How many bars do you see lower than 501?
1, 2, 3.
Add them up.
Okay, I understand you now. So that's 30 and then 40, 48, 48, 56.
48 and 6 is what?
48
Plus 6.
plus 6 is 54.
That's right. Very good.
Yes, 54, yeah.
Now you understand how you solve these problems with the bar graph, right?
Okay, yeah.
Any questions on bar graphs?
No, miss, getting it, get it.
Now, these bar graphs are vertical, but they could have been horizontal. In other words, these graphs could have been going in this direction from here to here. So bar graphs can be vertical like they are here, or they could be horizontal. And I'll show you a picture of a horizontal bar graph. No questions on bar graphs.
No, miss, thank you.
Okay, so you see this again, you'll be able to answer it, right?
Yes, miss.
Because I was surprised that I think
Nobody can.
no, I think
was-
one person had it right, but there were
Okay,
2 or 3 that had it incorrect.
okay. How many
Now-
of us in the class, Miss Barbara? 2, 3?
You mean right now?
Yeah, Maureen.
1, 2,
Alvo.
3, 4, 4.
Oh,
Yeah,
Chelsea not there?
Chastity is here,
Okay,
Mercedes, Alva, yourself, and Maureen. So 4 in the
okay, 4
class
of
now.
us, yeah.
Now, a pictograph, what is a pictograph, Mercedes?
I think a pictograph is a bars are showing, can be pictures.
No, it's
or
not
colors.
bars.
Not bar,
Photograph.
a graph that's showing, pictures or colors, of objects.
Well, it doesn't have to be colors, but it must have pictures. Pictures are representing items in the graph. All right,
Okay.
that's why it's pictures.
Okay.
Okay.
Oh,
Now I gave you Campbell's Flower Shop. Now, when you look at this pictograph, each flower represents how many flowers?
each picture.
Maureen,
Okay, sorry.
Maureen.
4 flowers.
Each picture represents how many flowers?
2 flowers.
No. Flowers per 100.
Oh,
So each
oh,
picture represents 100 flowers.
oh.
January, how many flowers were there?
200.
200. That's right, because you
Yeah.
had the 2, and
Yeah.
2 times 100 is 200.
Uh-huh.
Okay, Alva. May,
I
how
made a
many
mistake.
flowers? How many flowers in May, Alva?
150. I would say 150 because.
How many flowers do you see for May?
Oh, May. Okay.
May, right?
Yes, yes.
How many?
300.
300.
Yes.
How many flowers for November? Alva, how many?
I have something on my computer that blocked that. It's I cannot see it good, Miss Barbara. I have this thing there. It's a joint meeting. It's right in
250.
the. Huh?
250.
250. Maureen,
Yeah,
that
but
was
I
you,
can-
right?
I cannot
Yes.
see that part. It
Okay,
blocked.
I was telling
you
Alva.
have 200, and then you have a half of a flower. Half of 100 is 50. So that would be 250 for November. Alva, can you see July?
Yes.
How
it's-
many
yes.
flowers for July?
I would say it's 250.
That's right. Half of a flower here is
Yes.
50 and 200. How
Yes.
many for April, Mercedes?
That would be 150.
150, because you have a flower and a half of a flower. So now you know how to read the pictograph, right?
Yes.
Now I think all of you got number 2 right. Which month had the highest amount of flowers?
February.
Because February had how many?
1, 2, 3, 4, 5.
500, right?
Right.
So I
Yes.
think everybody answered that right. That was February. Okay. Now, let's go to the next. How many more flowers were sold in May than November? So, how many flowers were sold in May, Alva?
300.
So May had 300 flowers, right? 300.
Yes.
Okay. How many were sold in November?
250.
250. So November had 250. So what's the difference? What's the difference?
Between
300 and 250.
well 50 50 difference.
That's right. So that's your answer. In May, you
What is that?
sold,
Which
yes.
question is that? Which question was that? Number.
Okay, I skipped number 3. I'll come back to that.
That's right, that's what I'm
Okay,
thinking.
number 4. How many more
Can you
flowers
hold
were
on, Miss? I'm
sold
sorry.
in May than November?
Oh, Miss, can you hold on a little bit? Your picture is blocking some of the readings.
That's what happened to me here. That's why I'm not seeing it
Well, it's
clearly.
not blocking on mine, so I guess
I-
you're on the phone, right?
Just scroll on a little bit, you will go under you. Just a little bit. No, that's it. That's it.
And you see it? Okay.
Yes.
How many more flowers were sold in May than November? And Alva said May was 300, November 250. The difference is 50. So your answer would be 50. And I think most of you got that one right.
Yeah, that's
Now,
my number. Yeah.
Maureen, can you see which month had the least amount of flowers?
September.
That's right. September only had the 100, right?
Yeah.
So number 3 would be September. Okay. Now, I think everybody got these pretty much right. But when you got to number 5,
Oh no.
then I think we had a problem.
Yeah.
If the profit for each flower is $5, how many profit did Ken
How
Flower
much
Shop make?
profit, Maureen? How much profit? Go ahead, start over.
Okay.
Maureen,
If the profit for each flower is $5, how much profit did Ken Flower Shop made in December?
okay, let's look at December. So how many flowers do we have in December, Maureen?
4.
Each one represents 100,
400.
400. So you had 400 flowers. How much are you making on each flower, Maureen?
$5.
So what's that equal to? What's the
Two-
answer, Maureen?
2,000.
2,000.
How you do that, Miss? You
Questions?
multiply. How you do that? How you get 2,000?
All right. Mercedes, read number 5 again.
If the profit for each flower is $5, is how much? Because I can't see the rest of the reading.
How much profit?
How much profit did Kim's Flower Shop made in December?
Now, how many flowers were sold in December, Mercedes?
In December, we have 400 flowers sold.
Okay, so if you made $5 on each flower, how would you find the total profit?
If you make $5 on each, you gotta multiply.
That's right, which is what we did, right? $5 times 400 flowers gives you $2,000. Did I answer your question, Mercedes?
Oh Lord, I didn't expect that I think, I don't know why I put 5.
What's wrong, Mercedes?
I just can't comprehend why did I put 5. What was I thinking? I'm thinking that
Mhm.
say-
Profit for one flower times number of flowers will give you the total profit,
oh, total profit. That's what I didn't, I
right?
missed that. The total profit. That's what I missed.
How
Everybody
much
do-
profit did Kim's Flower Shop make in December? So you look at the number of flowers, Maureen gave you the 400, and
Mhm.
400 times the profit from one flower, $5, and that
Okay,
gives you 2,000.
so what I should have done, add up all it would be $4, $5. So to get all, okay, you add the four,
The 400 is on the pictograph right here.
yeah,
You see 4 flowers, each one represents 100. 4 times 100 is 400. Right? That's how you got the 400.
This Barbara, when I went back over I get my right because I didn't realize that it is the 100 flowers the other side. Yeah.
Oh, you didn't realize? Well,
No,
you
that
didn't see
no,
the flowers per 100. So
nah,
each one of these flowers represent 100.
yeah. I was
Okay.
just saying like 1, 2, 3.
Okay.
That's why.
Now suppose I had November instead of December. Mel, say, what would be the profit?
okay,
Bring one from.
the profit would be $1,000.
How many flowers? November
Or 250.
was 250 times 5.
You know this. Uh, so, so 5, 10. 1,200. Don't tell me I didn't do
No, what is it?
1,200. Don't tell
No. 5 times 250? Isn't it 1250?
Yes,
Maureen, what's 5 times 250?
1250.
Oh,
That's
I know what
right.
I
Alva
did.
got it right. Yes.
Miss, what I did was I multiplied by 4. I multiplied by 4 mentally.
Okay.
Sorry.
All right. See, November had 200 and then 50, right? 250, half right here. So 250 times 5 is 250. Any questions on pictographs?
No.
I think we are getting it, Miss Bauer.
You getting it, right?
Yeah.
It's where you have a picture represent a quantity, and they give you that in the pictograph. That's why they say flowers per 100. So each flower represent 100. Any questions on pictographs?
No.
The key there is the picture and what it represents in the graph. So you look at the graph, look at the symbol, and see what it represents. Okay. Now we're going to exponents and radicals. Before I do that, I think I want to bring up, let's see if I can.
We're gonna do number 6.
Yeah, I want to, well, before we do that, I wanted to look at,
Michelle,
I think I
Michelle.
had,
when you finish, can you see if you can get this off the computer for me? It's blocking my view with some of
can
it.
you see the properties of exponents here?
Yes, miss.
Yes?
Yes.
Maureen, can you see this on your screen?
Yeah. Yes,
Okay,
yeah.
all right.
I-
Now,
You see this thing here?
I think I gave you these as choices for you to for the answer
You
to
did,
the
miss.
question.
That's right. Yes, miss. But
All
it's
right.
a choice.
Now, the first one,
Yes. If it comes back, this person got it.
No.
x to the n times the dot means multiplication, x to the m, and you add the exponents. That's called the product of powers. Product is what you get when you do what operation, Maureen?
Product. is when you add,
Add is sum.
multiply,
Multiply, that's right. Product is result of multiplication. This is a multiplication, add the exponents. So you put some numbers here, 2 to the third times 2 to the fifth, 3 plus 5, 2 to the 8th. Now remember, they must have the same what? Base. X is the base here, 2 is the base here. Any questions on product of powers, multiplication of exponents?
Can you please just repeat that, miss? I'm sorry.
Okay, this number 1 is called product of powers. So when
Okay.
you multiplying exponents with the same base, you
Okay.
add the powers.
Okay.
X is the base, X is the base, N plus M.
Okay.
Put some numbers in there, 2 to the third times 2 to the fifth, add 3 plus 5, 2 to the 8th.
Okay.
Got it?
Yes, ma'am. And
Now,
number 2 is same like, sorry,
number
miss.
2 is quotient of powers. And quotient you get from what, Mercedes? What operation?
Divide.
Divide, that's right. When you divide, the result is called the quotient. So in that case, you subtract the exponents. Subtract the exponent from the denominator from the exponent of the numerator. So x to the m, n over x to the m is x to the n minus m. Put some
Okay.
numbers in there, same base of 3, 8
Okay.
minus 2 gives 6. Any questions on division
No, thank
of
you, miss.
exponents? The third is called a power of a power. That means you have a power of an exponent multiplied by a power outside of it. So x to the n raised to the m power is x to the n times m. So if you had 5 to the 4th raised to the 3rd power, you multiply 3 by 4 and you get 12. So that would be 5 to the 12th. Any
Okay.
questions on power of a power?
No, miss. Thank you.
and so how you get the 5 and the 4? When you say
I'm-
X,
It's just an
Say
example.
No, instead of x, Maureen, I'm putting a 5 for the base.
okay, uh-huh.
Okay. I'm putting a 5 for the base. Here I had a variable
Oh,
x, right?
I see,
But now
yeah.
I'm just plugging in a number. So
Oh, I see.
5 to the 4th power,
Oh,
and that's raised to another power of 3.
uh-huh,
You
oh, I see.
multiply the exponents. You got it?
Okay, yeah.
And you get 12.
5 to the 12th. That's right.
Yeah.
So power of a power, multiply the powers. Got it?
Yeah.
Now, number 4, and that's the power of a product. So that's a multiplication. This parenthesis is not really clear, but it should be parenthesis x times y raised to the n. That's the same as breaking this up into x to the n times y to the n. So you can have a product within the parentheses, all raised to the 7th, right?
Yes.
So that's 15 to the 7th, or you could break it up 3 to the 7th times 5 to the 7th. That's called power of a product. So you have a product within the parentheses and you're raising it to a power.
Uh-huh.
Question? And of course, 5 is a power of a quotient. That's quotient division. X divided by y all raised to the n power. Same as numerator x to the n over denominator y to the n. And there are some numbers. 2 to the 2/3 raised to the 5th power is the same as 2 to the 5th power over 3 to the 5th power. Any questions on that chart? Because I gave you that chart in one of your homework problems.
Yes, I do see it. Miss. I get a study.
Okay. All right. So let's go back to,
Okay, so it's like you're adding number 5, you're adding.
number
because-
5 is, no, this is division, Alba.
Okay,
X divided by Y.
yes,
That's why we said power of a quotient, because
Yeah.
quotient is the result of a division. 4 is a multiplication. 5
Yes.
is a division. Except your division is raised to a power. That's why you say power of a quotient.
So X divided by Y.
Yes, that's right. X divided by Y, all raised to the n power.
And power.
And you
Okay.
can write this as numerator x to the n divided by the denominator y to the n. Okay. And with the 2 over 3 to the 5th power, that's 2 to the 5th power divided by 3 to the 5th power.
And that will be the final answer, Miss.
Well, the final answer would be you get 2 to the 5th and 3 to the 5th,
Yes, that's what I'm asking.
and then divide it and get a number.
And
Plug that
divide
in
that-
your calculator and then get a number and do the same for the denominator and then divide it out. Now notice these don't have the same, they don't have to have the same base. That's why you say X, Y, X, Y. They don't have to be the same. Okay? Any questions on this chart? Okay, let's go back to our homework. Let's see. Okay, now you see number 6, which property is used? Yes?
Yes,
Mhm.
Miss.
Okay, now let me just bring this over to next page because I want to expand that. The property chart, I want to make it bigger. Let's see. Okay, let me just make this chart bigger. Okay, Alva, you see it says which property is used. Now you have 5 properties. We just went over them, right?
Yes.
Okay, now here's the exponents. We look at that. Let me make that bigger. Okay. 3 to the 5th times 3 to the 2nd times 3 to the minus 3. Remember, exponents can be negative, positive, or 0 times 3 to the 4th. Now, what kind of operation is this, Alva? Addition, subtraction, multiplication, or division? Alva?
Isn't it multiplication?
That's it. Very good.
Yeah.
Multiplication. The
Yeah.
X here is represent the multiplication. We had
Yes.
dots and we use asterisks, we use parentheses, but right
Yes,
here we
we use
X.
different things.
Okay,
yeah.
so this is multiplication. Now notice they have the same base. And what's the base here, Abba, in this example? What is the base? Exponents have base and then the power. Power is the exponent. The
Is
number.
the exponent, the base is the.
What is the
multiplication.
base of this expression? What is the base?
The 3?
That's it. Very good.
Yeah,
3 is
yeah.
the base, and these numbers here represent the powers
The powers.
or
yes.
exponent, right? So
Yes.
when we multiply and we have the same base, what do we do with the exponents, Alba?
You had them.
That's it. You add them.
Yes,
So
yes.
look at these properties. Which property does this represent? 1, 2, 3, 4, or 5?
1.
That's it. Very good.
Yes.
Did everybody get 1? Very good, Emma. Answer is 1 because 1 has what? Same base, raised to a
Yes.
power, add
Yes.
the exponents. Here you
Yes.
have the same base 3 and you
Yeah.
have exponents. And if you solve this, you would have the 3 add 5, 2 minus 3, 4.
Yes.
That was all the answer?
That was it. Answer 1. I asked you which property is used.
Oh,
And 1, 2, 3, 4, 5. Property
okay,
used is 1.
okay.
Got it?
Yes, ma'am. Thank you.
That's why I went over it first to make sure you understand the properties. What would be the answer here, Maureen, for this? If you multiply this out, what do you get? 3 to the what? What would be the power?
You did the power forward?
No, I want you to multiply 3 to the 5th times 3 to the
Oh.
2nd times 3 to the minus 3 times 3 to
Oh.
the 4th. What is the power you get when you add those powers? What do you get, Maureen?
Is it 8? It's
Chasta said 8.
third to the 8th power? If I'm not.
Anybody get anything different from what Chastity has?
Yes, miss.
What did you get, Mercedes?
I got I got 3 to the 37th power.
You said 3 to the 37th? 3 to the 37 power? Is that what you
Yeah.
said?
Yes.
3, 7.
Hold on. I multiply.
Any other values? Anybody get anything else? I have 2 answers here. Any other answers?
Trying to figure it out because you're multiplying the powers.
3 to the power 7?
5,
I got
5,
another one, 3 to the
10,
7.
10.
Okay.
What?
Okay.
What
Three is
Maureen said?
30.
Maureen said 3 to the 7.
Okay.
So let me
Okay,
put a 7 there.
don't you have to subtract out the 3, one of the 3? That's a minus.
This property is 1, right?
Yes.
It's using 1. You add up the powers. So the answer that Chastity said is the correct one. 5 plus 2 and a minus 3 and a 4.
Yes.
I never heard of multiplying the powers. I don't know.
You do when
4
you
and
have a
6.
power to a power, Chastity.
Okay.
But this is not a power to a power.
Oh, power to power. I didn't know that.
See, number 3, power to a power, you multiply. 4 times 3 is 12. But here, you just have same base and a power. You add up the powers. So you add 5 plus
And
2
7.
and a minus 3.
3.
What does that give you, Alba? What's a 7 and a minus 3?
A minus 3, that's 5.
No.
Oh, a minus, okay.
7 plus a minus
7.
3 gives you what?
10.
No. Subtract when the signs are different. You got to know your sign rules.
That's what I'm saying. I would subtract the 3 from 7.
And you get what?
4.
4. And then what's 4 plus 4?
8.
8. There's your answer right there.
Yeah, that's what I was saying because it's a minus 3.
There's your answer.
So I was gonna add up
Now,
all of it. and
Mercedes,
then
how did you get
subtract.
3 to the 37?
Okay, I says 5 2 is 10 and 10 4 is 40.
Wait. You said what?
2 5 is 10.
You're adding.
You're not multiplying.
You're not multiplying the powers. You're adding the powers, Mercedes.
Okay, that's
So
what I meant.
how do we get 3
I multiply. That's what
to the
happened.
7 power? Is that's not the answer, right?
The answer is what you said, Chastity, 3 to the 8.
Okay.
That's the
I
answer. I'm
probably
just
thought
trying to find out how Mercedes got 3 to the 37.
I
Then
add up
multiply.
all of the powers, Miss Barbara, and then I subtracted 3.
Why?
But Mercy multiplied. She
Yes,
said three, she said 5 twos, right? It's
it's
10.
10.
10
And
4
10
is 40, and then
40.
she take away the 3 from the 40. That way she get 37.
Yes, that's what I did.
but
No,
the way
you
I did,
add. You
see, the way I
add.
did it, it was like 5 plus 2 and then minus 3 and then plus 4.
Yeah.
Yeah, I understood that completely, but what I did, I thought I should have multiplied.
No, you add the powers. So this becomes, okay, this is the way it would look. Okay. You'd have 3. Okay.
Miss Barbara, what is it that is you know, you have a few problems here, 1, 2, 3, 4, 5, and on the side has numbers.
Well, these are not problems. Those are properties.
Okay, properties, yeah.
Okay. Minus 3 plus 4. Now, when you add this up, what do you get? Mercedes.
Oh, when I had up,
Barbara, I'm sorry, I'm driving, okay?
Okay. Okay. 3 plus 2 minus 3 plus 4. What do you get, Mercedes, when you add it up?
3 plus 2, that's 5.
Right?
And if you minus 3 from 5, you're left with 2.
No.
What?
5 minus 3 is what?
2.
You got 3 plus 2 is 5. And a plus 5 and a minus 3 gives you what?
Oh, you're subtracting.
Yep.
1.
What was that?
1.
3, 2,
This is, I'm sorry, this should be a 5 here.
5 plus,
That
because
should
5
be
plus 2.
That's a 5. Sorry. Okay. So this would be a 5. Let's put the 5 there.
Oh, yeah, that's 5.
I just want to put all the exponents there so you see how you got your answer. Okay. So Mercedes, start back over. 5 plus 2 is what?
7.
5 plus 2 is 7.
And 7 minus 3.
4.
And 7 minus
Mercedes.
Plus
7
10.
minus 3, Mercedes.
3, 4,
And 4 plus 4.
make it 8.
That's why you get Chastity's number 3 to the 8.
Yeah, what I did, if it was multiplication, I'll get it right, but because the multiplication naturally misses right, but
But
all
this
were
is
wrong.
multiplication.
I know.
Multiplication with the same base, you add the powers. That's why
Okay.
we have 5 plus 2 minus 3 plus 8. I mean plus 4.
Okay, so what I should put in my head is once you have the same base, you're going to add.
When
The
you're
exponent.
multiplying with the same base, you add the powers, add the exponents.
Multiply.
Got it?
Yes, miss, thank
Whether
you.
it's 4 like here or whether it's 2, doesn't matter. You add the exponents, add the powers. Maureen, how did you get 3 to the 7?
I know, I got clue.
How did you get 3 to the 7?
I want to just add the flavor too.
Oh, you left out something. Okay, so the answer would be 3 to the 8. 3 to the 8. All right, let's just put it here. That would be the answer. Any questions on multiplying
No, thank you. miss.
exponents with the same? Turn your phones off, please.
Yes,
Turn
Miss
your
Barbara.
phones off.
Okay.
Turn your phones off, please.
Can't find it. Oh, Lord.
Mute.
But you should
Just a
have
minute.
those devices muted when you're doing our session. Turn your phones off or put them on vibrate, okay?
Okay, Miss Barber. Yeah.
Okay, so multiplication, add the exponents. Any questions? So number one, that's the property, that's a multiplication, add the exponents. All right,
Okay, miss.
now let me just do, before we go to the next question, before we go to 7, just want to do another one of these where you use the property. Okay, let me give you this. Okay, all right, let's take 5 to the second power, and we want to divide that by 5 to the third power. What's my answer, Maureen? What's the answer? That's a division, right? Subtract the exponent. So what do you get, Maureen?
Simplified problem number 7.
No, we're doing this. I'm doing a division here.
Okay.
5 to the second divided by 5 to the third. That's number 2 here of properties, right?
Okay. Okay.
And number 2, you subtract the exponents. So Maureen, what do you get? What's your answer?
5 to the power 1.
No,
Subtract 2 from 3 is 1, right?
you subtract the numerator, the denominator exponent from the numerator. So that would be a 2 minus a 3. What is that equal to, Maureen?
1.
What is it? What is that equal to?
Okay.
5 to the 2 minus 3. What is that equal to?
Oh,
Make that bigger.
22.
What?
5 is
Okay.
22.
5 to the second minus 3. What
5
is
to the
that
second.
equal to?
That is 5. 5 is 25 minus 3.
What do you get, Mercedes?
I get 5 to the 1 power.
No, what do you get, Alva?
Which one you're doing, Miss Barber? Number 2?
No, no, this is not on your sheet. I just wanted to do
Oh,
a
okay.
division to make
Okay.
sure you apply the property correctly. So subtraction is of the exponents when you're doing a division. So this becomes 5 to the second minus 3. What is that equal to, Alva? That would be 5 to the what? What power?
Okay, 5 to the second minus 3.
Yeah, what would be the power?
And you're subtracting from the
100.
power?
Yes, so what would be that? What would be the power?
5 to the first?
No,
Power?
no.
I don't know that one.
What's a plus 2 and a minus 3, Alva?
A plus and a minus
A
is
plus 2 and a minus 3 is what?
Oh,
you had,
Ye-
isn't that? A plus and a minus you had?
So what would be a plus 2? You gotta remember your signs now. A plus 2 and minus 3. What's that equal to, Maureen?
I know. Minus 5.
No,
Minus 1.
minus 1. Thank you, Chastity. Minus 1. Remember, unlike signs add and subtract, So you subtract the 2 from the 3, you get a 1. The number with the largest value has a negative, so this becomes a -1.
Oh, that one is a little tough for me to understand.
No,
So
you
that,
got to
so
go
that
back
is,
to your signs.
oh,
Remember, I went over sign rules. You need to review your sign rules. Plus and a plus
Yes.
adds to a plus.
okay.
Minus and a minus adds to a minus. When you're adding a plus and a minus, you subtract.
I forgot the sign.
The
It's just
sign is that of the
Yeah.
number with the greater absolute value, which is the 3. The 3 has a negative, and that gives you -1. Or if you look at this, you've got more negatives than you have positives, so your answer has to be negative. Got it?
No, I see. Oh.
So
You
this
have more
one,
negative more than positive.
yeah, you have more negatives. You have 3 negatives and 2 positives. Your answer has to be negative.
Okay.
So this is 5 to the -1, right? What's another way of writing that? Anybody want to tell me? What's
Well,
another way of writing 5 to the -1? Anybody want to tell me? How else could you write that? How would you write that as a positive exponent?
1/5.
That's right. Thank you, Maureen. Because it's
But when
1/5 to the 1. Right. So when you have a negative, it's the reciprocal of the positive. So this will be 1/5 to the 1 power, which is just 5, right? You could put the 1 there, but you don't have to. Because any number to the 1 power is just a number. So that would just be equal to 1/5. You got it? You got to remember those signs. So 5 to the 2nd over 5 to the 3rd is 5 to the -1, which is 1 over the reciprocal to the +1. Got it?
thank you, miss.
Questions? Any questions?
No, miss.
Okay, let's go to simplify. Now remember, I told you you could take radicals, and this is the radical symbol. Underneath the radical, we call that a radicand. But you can write this in terms of 2 radicals, but you try to write it with 2 radicals where one has a perfect square root, right? So what are factors of the number 200 where one number has a perfect square root? Alva, can you think of factors? 2 numbers, let me just put 200. What are 2 numbers you can multiply and get 200? I'll just put parentheses. Okay, and now you just tell me what goes in the parentheses. What are 2 numbers I can multiply and get 200? One of the numbers having a perfect square root.
2.
Alva,
2, 110.
remember I say the 2 numbers multiply to give you 200. So give me 2 numbers you multiply and get 200. Alva, 2 numbers you can multiply and get 200.
Okay, I will say 2 and 100.
Very good, Alva. 2 and 100. So let's
Yeah.
just, that's it. Let's
Yeah.
put 100 there because a 100 has a perfect square root, right?
Yes.
So we have a 100 and a 200. So you want to find your factors, and those same factors, we can put them on a radical.
Yes.
All right. So you got your factors. Now let's just take our radical square root of 200. And instead of this 100, we're going to put radical 100. Okay? So let's just put this here. the radical 200 equal. Now let's just put, now this you told me 100, so let's just put the 100 here instead of 200. It's like I say, you can take the radicals and factor them into other radicals. So this would be, and this would be times 2. Everybody following me?
Yeah.
Yes, ma'am.
Okay.
Question, Miss.
Yes, Mercedes, question?
Are you saying that 10 and 20 couldn't work?
What?
10 and 20.
Does 10 have a perfect square root?
And I don't understand it then.
No, you want to pick one of your factors that have a perfect square root.
I did work, the way I did it, I get 100. I used 2, but I just choose because I said 10. 10 times 20 is 200. So I don't understand.
No. When you factor radicals, you factor them into 2 radicals.
Yeah, that's what I used. I did try 2 and 100, but I break it down. Then I said, okay, I'm going to use this 2 smallest ones. That's 10 and 20. So I don't understand the something there then.
But if you put, okay, let me just go back up here. 200, you said that's equal to 10, and you said 20. That's what you're saying?
Yes, miss.
But neither one of these numbers have a perfect square root. You know, what's the square root of 10?
Oh, so 5 or 2.
Square root. A square root is a number you can multiply by itself and get the number. Do you know 2 numbers you can multiply by themselves and get a 10?
Oh, 2 5s is 10. So
Well, the square root of 5 is 25, so that's why it cannot multiply there.
5 and 5.
Yeah, but that's 5 and 5 is not 5, and 5 times 5 is 25. So the square root of 25 is 5. But square root of 10 is not a whole number.
Oh.
Square root of 20 is not a whole number. You know what square root is? Square root, when you get the square root of something, you're getting a number that you can multiply by itself and get back that number. Like 100. The square root of 100 is 10, because 10 times 10 is 100. You see, Mercedes,
yes, I understand that, but I just don't get the script.
yeah. See, when you break this into factors, you want to then break the radical into radical factors, but you want to use numbers that have perfect square roots. Did I give you a list of some of the perfect squares? I think I did. Like square root of 64, square root of 49, square root of
I don't think
36,
I have that.
square root of 16. No, I gave that, I think I gave that to you in, let me
Me?
make a note where I send it. I'll send it again. Okay. Okay, send perfect squares. I did send it. Maybe some of you didn't get it. I'll send it again. All right.
Thank you, miss.
But you know some of them. What's square root of 4, Mercedes?
That's 2.
Because 2 times 2 is 4, right?
Oh,
What's
that's
the
what you
square
mean?
root of 9?
3.
3. So when you get the square root, you get a number when multiplied by itself will give you what you have under the radical.
Oh, so you're saying the square root of 10 would be 5. No.
No, the square root of 10, there is no whole number for square root of 10.
Okay, and there's none for 20 either.
That's right.
Okay,
Whereas
I think
16 has a perfect square root, right?
yeah, because
what's-
8,
Square root of 16 is what?
2 times 8.
No, what's the square? No, you can't say 2 times 8. Remember I said by itself.
Oh,
The two numbers are identical and multiply to give you the square root. So square root of 16 is 4 because 4 times 4 is 16.
okay, got you, got you.
All
So,
right.
oh,
So,
no, I get in the picture there, that.
okay. So it has to be multiplied by itself. Just like you say, let me just take here.
Because I work it down from 2 into on 200, make it 100, come all the way down to 10 and 20. That is,
No, what's the square root of 100, Mercedes? What's the square root of 100?
10.
10, because 10 times 10 is 100. Remember I said a number by itself. In other words,
Yeah.
the two identical numbers multiply to give you the number under the radical. So this
Okay.
would be square root of 100 is a 10. So we put
Yes.
our 10 here. Take out the 0. And there's our answer. 10 times the square root of 2. That's the answer.
What you see right here, Miss? 10 times the,
Square root of 100 is what, Mercedes?
10.
10. So square root of 100, I put my 10, and then I just leave the square root of 2 because the square root of 2 is as simplified as it can get. There's no number I can multiply by the same number and get the 2. Question?
Thank you, Miss.
Any questions? Maureen, did you get that one?
Yeah.
Okay. Because once you factor the 200, the 100, and the 2, you say, okay, the 100 is a perfect square root. So I can factor my square root of 200 into square root of 100 times square root of 2. So you want to try to get a perfect square root. So then you can get that square root and then simplify your number. Instead of square root of 100 times square root of 2, you have square root of 110 times the square root of 2. Now this is as simple as you can get it because 2 is a prime number. And your prime numbers are never perfect square roots. All right? Like 3, no perfect square root. 5, no perfect square root. 7. But 9 is a perfect square root because it's not a prime number. Questions?
No, thank you, Miss.
All right, now let's go to, okay, so try number 8. Square root of 24. Think of factors of 24.
4.
Factors, you got to give me 2 numbers, Chastity.
Oh,
Factors mean 2 numbers multiplied to give the number. So what are you saying your factors of 24 are? What 2 numbers will you use to give 24, Chastity? Multiply to give 24. Chastity, what are 2 numbers? Maureen, you know 2 numbers? Multiply to get 24.
thank you.
Maureen?
4 and 6.
Okay, so Maureen says 4 and 6.
Okay, yeah.
Any other numbers?
I'm sorry. I'm
Can I
gonna
do 12?
And 2.
Mercedes, you said what?
Hey, Miss Barbara,
Yes.
I have to mute. There's a lot of noise around me.
Okay, all right. Now, Mercedes, what did you say?
I was saying 2 and 12, but then I changed my mind. No.
Oh, you changed your mind? Okay. 2 and 12 are factors. But neither one have a perfect square root, right? But
Okay.
Maureen said 4 and 6. And what's the square root of 4, Alva?
16.
Square
Or
root
4.
of 4 Number
Oh.
that multiplies to give you 4. What is that number?
Oh, 2 multiplied by 2.
That's it. Very good.
Yes.
So square root of 24, let's just put it here. We can write that as square root of 4. So let's just put square root of 4 and times the square root of 6 times square root of 6. Now, Alva,
Yes,
what is
sir.
that equal to?
Sorry, miss, you can see your writing a bit low on the left or left.
Can you see it now?
Yes, thank you.
Okay. Okay, Alva, what would this simplify to? What's the square root of 4? You just told me. Tell me again.
Oh, you want me to repeat the answer?
Yes, what's the square root of
A
4?
4. 2.
2, that's right. Okay.
Yeah.
So the square root of 4 is a 2, so we put a 2 here. And we just leave the square root of 6. Square root of 6 is not a perfect square root, and that's your answer. Now the square root of 6 can be factored into 3 and 2, but they both prime numbers. So
Yes.
once you get prime numbers, you just leave it. There's your answer. 2 times the square root of 6. Questions?
No, we're getting there.
Okay. All right. Before we look at the next one, I want you to tell me, let me give you another radical here. Okay. And this would be 98. Simplify that number. Anybody got the answer? Let's say these. What are some factors of 98?
Factors of 98.
What are two numbers you can multiply and get 98?
That is that 1 sec. Let me make sure I'm right. No, is that
Maureen?
Is it 10 and 8?
10 times 8 is 80, Alva. You must
Oh, 10.
multiply and get 98.
Oh, okay.
Give me two numbers you can multiply and get 98.
Mhm.
Think half of 98, Alva. What's half of 98?
Off of 98.
In other
is,
words, 98 divided by 2 is what?
9?
Okay, is
Alva?
two nines.
What is it, Alva?
No, I'm saying,
What's half of 98?
I know half of 100 is 50.
So what's half of 98? What's 98 divided by 2? That's mental math.
49. 49.
Maureen, are you Alva? Maureen, you change your name?
Yeah.
Just for the day, right?
Well,
Okay, now I want Alva to answer. Alva, what's half of 98?
Can't come up with it yet, Miss Barbara.
Sure you can. Half of 98. 98 divided by 2.
Okay,
you hear me?
let me work it out. 98
Divided by 2.
49.
49. So
Yes.
this could be what? 2 times 49,
Yes.
right? Now 49 has a perfect square root. Alva, what's the square root of 49?
7.
That's it. Very good.
I'm
So,
bright.
all right. Yes. Thank you, Alva.
I
Okay,
wish
so-
everything could come to me so clearly.
Okay, it will come out, but you'll see. Practice makes perfect. So
Yeah.
this would be, we can put our 49 here, right? Square root of
Yes.
49. We break this up into the two radicals. And we said, you said a 2, so then we put a 2 here.
Yeah.
All right. And square root of 49, you say that's a 7.
Yes.
Now let's just put our square root of 2 here. And that's your answer. That's it.
Okay. Yeah.
Get the 7, miss.
Okay. 7 and 2.
7. Square root of 49 is 7. Mercedes. Albert just
Oh.
said. 7 times 7 is 49. A number times itself gives 49. 7 times 7.
Okay.
Right?
Yes. I mean, oh, you add up to, and then you said 2 times 49 is
98. Yeah.
Yeah, 2 times 49 is 98. So that means I
So-
can break up my radical 98 into the radicals 49 and 2.
So that's how we get the 7 and the 2.
That's right. The 7
Yes.
and the square root of 2. So
Yes.
you got your factors, then you can break them up into radical factors. Square root of 49 and square root of 2. Square root of 49, perfect square root 7. 7 times square root of 2. That's your answer. Square root of
So the answer-
98 is 7 times square root of 2. That's your answer.
so the answer is 2 times 49, miss.
No, the answer is 7 times square root of 2. Here's your answer right here. 7 times square root of 2. That's your answer.
So what I want to know is you have to have for the answer.
But Miss
49.
Barbara, okay,
What are you saying, Mercedes?
So you have to have the answer. The answer should be written like you have it there, miss. 49 and 2 equal to
Yes,
7.
you always put the number with the perfect square root in front of it. That becomes a coefficient of the radical that follows it.
But what I want to make sure is that these two answer you have there, that's how I should put the result for 98.
This is, you should write it just like this. 7 times square root of 2.
Just 7 times square root of 2.
That's it. That's the answer.
Oh, I got you. Because
Because 2 is a prime number. I can't factor that anymore.
yeah. So
right?
right away, anybody sees, you know, that 7 times 7 is 49 times 2, making it 98.
No, factors of 98 are 2 and 49. That means factors of square root of 98 are square root of 49 and square root of 2.
No, miss, I'm talking about 98 answer. I am saying if you have 7 with the square root 2, am I calling it wrong?
Keep going.
Anyone look at it, if you put that for the answer for 98, anyone look at it, we understand that 7 times 7 is 49 times 2 give you 98. Am I saying it wrong?
No, I don't understand what you're saying.
If I should put the answer 7 with the 2 for the 98 answer, would that
You
be
mean
correct?
7 with the square root of, not 2.
Yeah,
That'd be 7 times square root of 2.
I would have to put the
Radicals
sign.
factor into other radicals. And when you
Yeah.
finish the factoring, you will normally have a radical in your answer. Not always. Sometimes it can just be a number. But usually there's a radical in your answer. Now, the only way, like here, if this was a 4, then that would be a 2, and then a 7 times 2 would be 14. But see, I can't factor square root of 2 into anything. That's a prime number. My prime numbers as radicals are not factored into anything. So if it's a square root of 2, I leave it. Square root of 3, square root of 5, square root of 7, square root of 11. Got it?
Yes, but I don't think you understand what I'm asking.
Okay, ask your question again, Mercedes.
If the answer could be 7 under 2, and someone will understand it that 7 times 7 is 49, and you multiply that by 2, you get 98. If the answer stands for 7 under 2.
No, you have to get the radical square root of 98, Mercedes.
Okay,
And
so
what you're saying, you're not getting the radical. You're just getting a number.
okay.
Remember,
So
you're simplifying a radical. So you can
okay.
break it up into two other radicals. Hopefully one has a perfect square root. So your answer would be a number represent the square root of that radical that has a perfect square root, and the other radical that does not have a perfect square root.
Okay, so 2 times 49 would be perfect, or 49 to the 2 is okay.
You don't understand it right.
Mercedes, there's only one answer. Let me just put it here. There's no substitutes here. Okay, let me just shake this out. Okay, square root of 98 equal, and there's your answer. That's it.
I can't see it, miss. Yeah, scroll up a little bit, please.
Okay. That's your answer.
Okay.
This is your answer right here.
But that's what I'm asking you.
That's not what you asked me, Mercedes. You were not using
Oh.
radicals. I'm saying you can't just tell me 7 times 2.
No, that's not what I'm saying either.
Okay, say
I'm
it
saying
again, please.
If I'm saying if you have, just like when you put it there now, 92 equals 7, whatever the sign name with 2, when somebody see that answer, right away they will know that 7 times 7 is 49. Multiply by 2 give you 98. So that answer is okay. I'm just, when you argue out a math, you get it clear in your head. So I'm saying which one would be better then? Better answer, the 49 with the 2 or the 7 with the 2?
No, this is not the answer. You mean this right here?
No, the bottom one is the answer, right?
This is
This
the
one.
answer right here.
Yes.
This is just a step in the answer.
Good. So
You can't
correct.
just give me square root of 49 times square root of 2, because 49 has a perfect square root. You have to give me the square root of the 49 to 7.
Oh, and I know you lead right back to 9. So what I'm thinking, I'm correct, miss. You might not get me, but I know what I'm saying. So I'm correct. So I thought you were saying that the 49 with the 2 is the answer. But now that you say that is 7, it's in my head clear.
Yeah, there's the answer right there. That's why I put answer here, 7 times square root of 2. Normally these are given as multiple choices. So square root of 49 times square root of 2 would not be a choice. Okay, you got it?
Yes, I got it.
You'd have 7 times square root of 2 as one of your choices. And
That's why I was saying.
then you'll have some other choices, like if you made a mistake, and
Yeah.
if you put the square root of 49, that would not, because that would be not, it says simplify. So when you
Yes.
simplify, you want to get as fewer radicals as possible.
Yes, so that's why I'm saying. So if I have that answer, the teacher would understand that I'm trying to say that 7 times 7 is 49, times 2 give me 98.
No,
The
Yeah.
teacher doesn't have to understand anything at that point. They give you a multiple choice, you put the right answer, and they check it. But
I should do
I
that.
I know what you're saying.
I
The
know what you're saying.
98 came from a 49 as a factor of the 98, and that's how you got the 7. But when someone's checking, they're not trying to figure out if you had this. They just checking if the answer is correct.
All they're looking at is the right answers.
That's right.
And if it's not right, you get it wrong.
Yeah, when I
Yeah.
look at this and I say a 7, that meant something square root gave me a 7, and that could only be 49, which is one of the factors of 98, like I said up here.
Okay,
You got it? So
yeah.
simplify square root of 98. A, B, C, D. What are the answers? 7 times square root of 2. Other answers that would not be correct. You pick the right answer. That's it. Got it?
Yes, thank you.
Okay. Now, I want you to try another one. Okay. Let's try another one. Okay. Not 98. Let me do another one. Okay. Oh, let's see. Square root of 80. What is that equal to? Factors of 80. Alba, you know factors of 80? What two numbers multiply to give you 80, Alba? Think of two numbers you can multiply, get 80, Alba. One has a perfect square root. What are they?
10 and 8. 10, 8.
10 and 8, they are factors, but neither one have a perfect square root.
Okay.
Give me another set.
Okay, so
Two other numbers you can multiply and get 80. 10 and 8 are factors, but 10 does not have a perfect square root, nor does 8. Two other numbers, Alba? Can you think of two other numbers?
I'm kind of figuring what it would be, because I know if you multiply 240, it would be a bigger number. So 2 4s is 8. Is 2.
You're on the right track with your fours.
I'm saying it, but I can't come up with it. 2 4s is 8.
Two numbers you can multiply.
Okay, is it 2 and 10, 2 and 5?
2 times 5 is 10. Remember, I want to get 80, Alba. Two numbers to
Yes.
multiply to get 80.
2. Oh Lord. Can't come up with that one so quickly, Miss Barbara.
Maureen,
know-
two numbers.
I know 2 is in it, but the other one.
4 and
Maureen.
20.
What?
4 and 20.
Okay, let's try 4 and 20. All right, we'll do 4 and 20. 4 and 20. All right, we're gonna have to do 2 steps here, but that's okay. That means I can say square root of 80. Maureen said 4 and 20. Okay, so let's use Maureen's numbers. And let's put them in there as radicals. So that's 4.
Oh, that is a big, yes.
Okay,
it can work.
let's put the 4. Yeah, the 4 has
Okay,
can
so
work.
okay. Let's
It
do
can
4 and
work.
okay, and
do
then you
4 and
said
16.
It can work, Maureen. 4 and 20.
yeah, but you're gonna have to do 2 steps.
Oh, okay.
Okay, so Maureen, you said 4 and 20, right?
Yeah,
Now, what's the square root of 4?
2.
2. So let's put out 2 here. 2. And we've got square root of 20. But 20 can be factored, Maureen. What are factors of 20?
Um, 4 and 5.
4 and 5, right? Okay, so let's just put our 2 times square root of 20, copy it here. And square root of 20, you said 4 and 5, right? So I have 2, and let's take the 2 out here. And let's put the 4. And the 5. Right? So we factor in the square root of 20 into square root of 4 times the square root of 5. Now,
You're right,
Maureen,
Miss.
what is that equal to?
Okay.
Square root
2, 4,
What's the square root of 4?
2.
Okay, so let's just put that there. You said that's a 2. Square root of 4 is a 2, so that would be times 2. Let me put that there.
4.
And what's 2 times 2?
4.
Okay, all right, so let's just put that here. Okay, so 2 times 2 is 4. And so that's what, 4 times the square root of 5.
Miss,
Yes,
can I say something what we're doing there?
yes,
Because 4 times 4 is 16. Times 5, you get 80.
that's right. So you could have said what? Now, Maureen gave me what, 4 and 20? And square
Yeah.
root of 4 is 2. Square root of 20 is 4 and 5. So 2 times the square root of 20 is 2 times square root of 4 times square root of 5. Square root of 4 is a 2, and 2 times 2 is 4. 4 times square root of 5. Now, 80, you could have had, what other factor could you have had for 80? Go back up here. I mean, we did it in 2 steps here, but had you chosen 80, and that's okay, you get the same answer. Had you chosen, what are the other 2 factors you could have chosen here?
4 and 5.
No, 80, 2 numbers multiplied to give you 80. 5 and 16. And that give you 80?
Yes, miss, but that's why I say 4 and 5. Because you're going to
No, not 4 and 5.
well,
5 and 16, Mercedes. Remember, I said factors of 80. 2 numbers to multiply to give you 80.
hear me out first, miss.
Go ahead.
4, you have down here 4 and 5, right?
I have
And
4 and square root of 5.
yeah, and you're going to say 4 for 16. 16 times 5 is 80.
Yes, but what I'm saying, Mercedes, had you chosen 5 and 16 as your factors, you would have done it in less steps. Because
Yeah.
square root of 16 is 4, and 4 times the square root of 5. So what Maureen chose worked, but we did an extra step. So how
Yes.
you choose your factors determine how quickly you can solve your problem. Now, all these are factors of 80. 10 and 8, neither one perfect. 4
I'm
and
looking
20, 4 perfect. 5 and
Yeah.
16, 16 perfect square root.
So, miss, I'm looking at 4 and 5, just like how I look at 7 and 2. 7 is 49. By 2, multiply by 2, you get 98. 4 16, multiply by 5, you get your 82.
Yeah, but you have to have it as a radical though. I'll say these 4 times square root of 5. There's your answer. You can't just put 5. You got to put square root of 5. Got
Yeah,
it?
with the square, that's the answer right there, right?
Right there. That's the answer.
Yes, that's what I'm saying. I just don't call the square root sign name. That's what. But
Oh,
I'm
you gotta call them square root. 5 is not the same as square root of 5. Be very
No,
clear,
I
Mercedes.
understand. I understood you completely, miss. But
Yeah,
on
but
that,
I'm just saying when you given an answer, if it's a square root, say square root.
okay, so I
If
should
they're
have said,
not the same.
okay, I should have said then what? 4 square root of 5?
4 times the square root of 5. 4 is the coefficient and the radical is radicand is 5. That's the radicand underneath the radical.
So that's why you just say 4 for 16 times 5, you get your answer.
That's right. Square root of 16 is a 4, and then this is left. Remember, this will be square root of 16 times square root of 5. Square root of 16 is a 4, and the square root of 5, that's a prime number, can't be factored into anything other than itself and 1. Got it?
Yes, ma'am.
Okay. So now you know how to simplify your radicals, right?
Still
Yeah.
learning.
Okay. Now, you can also add and subtract with your radicals. And that means you add the coefficients, like 2 times square root of 2 plus 4 times the square root of 2. Alpha, what would that be equal to? What was this?
Where are you now, Miss Barbara?
I'm
Right at
over
number
on the
9?
right. Number
Yeah.
9. What would that be
Yeah.
equal to? Add the coefficients. Those are the numbers in front of the radicals. What would that be,
Yes.
Alpha?
Okay, 2 and 4, 6.
That's right.
No.
And
And you have 2
then,
plus 2.
no. Then I just have the radical.
Okay, you have 6.
6 and then square root of 2. That's it. That's the answer.
Yes.
See, you just add the coefficients when the radicals are the same.
Yes.
See, so, and when I said radicals, I'm referring to the radical and the radicand. I just refer
Yes.
to them as radicals. So
Yes.
that's like if you said 2x plus 4x. What would that be equal to, Alba?
That would be 6 also.
6 what?
6 is the
2x plus 4x would be equal to what?
2x plus 4x would be equal to the radical.
No, I'm not talking radicals here. I'm just talking variables. 2x plus 6x.
Oh,
Coefficient 2, coefficient 4. You added 2 and 4, you got 6, and then you just
Yes.
x. Then
Yes.
x. Can't throw away the x, right?
No.
Okay, so 2x plus 4x, 6x.
Yes.
So if I have radicals, I have a coefficient in front of each radical. I can add them because the radicals are the same. So 2
Yes.
plus 4 is 6, and then followed by the radical square root of 2.
Oh,
Yes.
Mercedes, that's clear?
yes, I just realized what you're saying.
Yeah, and that's why I use the variable here so you can see it's the same analogy here. Just add the coefficients, repeat
Bring
the
back
variable.
X.
Add the coefficients, repeat the radical.
Yeah,
Got it?
yes, miss. So,
Okay, so let me just take this. Okay. Okay, I have 3, and that's 32. And I'm gonna add that to 8 and 32. What does that equal to, Mercedes?
11, what you call the sign, miss?
11.
Yeah,
And what follows the 11?
I don't remember the name. What's the name of the sign?
The radical.
Radical. upon 30, 20, 30, 32, sorry.
That's right. Just repeat the radical because they're the same, right? So just take this the radical 32 and put it behind the 11.
Yes,
Got it?
yes, miss.
So you add the coefficients, 3 and 8, 11, and then just repeat the radical. And the subtraction, same thing, except you're subtracting.
Oh,
What's the answer here, Maureen? What's 7 times square root of 10 minus 10 times square root of 10? What's the answer?
It's 3. Minus 3.
Minus 3. Thank you, Maureen. Minus 3, because you subtract. 7 minus 10 is a minus 3, and then you just put the square root of 10.
upon 10.
There you put.
Okay.
Minus 3.
So now you know how to add and subtract radicals, right? Add or subtract the coefficients. Coefficients are the numbers in front of the radical. Questions? Now, the bonus 10 points, let's see. Let me bring this down. Now, how do you think you would solve this problem?
What is this simplified expression of?
What is the simplified expression of square root of 2? Just put, okay, square root of 2. Let me just write it here. Plus, and that's square root of 3. And if it's squared, that means you multiplying it by itself, right?
Yes,
Okay, so let's just put this parenthesis. And I want you to use FOIL and multiply this. You know how to use FOIL?
I have to look at the big diagram to do it.
I want you to know how to use FOIL because that can save you a lot. So let's just take this, multiply it by itself. That's what the square is. And, okay. Now, use FOIL. Maureen, how do you use FOIL?
You do first.
Okay, use FOIL. Okay, so F is the first. So let's just put our F here. So what are the first terms, Maureen?
2 and 3.
No. What are the first two terms here? Mercedes, you know the first two terms?
Is that 2 times 2?
I don't see a 2 here. I see a radical.
Radical. Oh, yeah, I'm not getting used to calling this name yet.
Yeah, you got to call them 2. Remember I say 2 is not the same as square root of 2. What do you see, Alva, as the first terms?
A radical and a 2.
Yeah, you see the square root of 2 and the
Yes.
square root of 2. So that would be, let me just put here,
But I meant, miss.
but you got to say it right, Mercedes. I told you the 2 is not the same as square root of 2. And I want it to sink in because you carry those mistakes over when you're doing the work, right?
You're right, miss.
Yeah, that's why I want you to see the square root of 2. So this is square root of 2 times the square root of 2.
2.
That's the first terms, right? Square root of
Yes.
2 times square root of 2. Now, Maureen, what is that equal to?
Hello, Miss Barbara.
Yes. Yes, Chastity.
The square root of 2 is square root of 2.
The square
Hello?
root of 2 times the square root of 2. Chastity, you know what that is?
4.
No, Miss Barbara, I'm sorry. I have to go. I have to go now.
Okay.
All right.
All right.
Thank you so much.
Okay.
I
All
will
right,
look at the.
Chastity.
I'll look it up on
Yes.
YouTube.
Yes, I'll
All
put
right.
it on YouTube.
Thank you. Have a good day, everyone.
Okay.
Bye-bye.
You
Okay,
too.
you too,
Okay.
darling. Yes.
Ava, what's square root of 2 times square root of 2?
2 multiplied by 2 is 4.
No.
Square root of 2.
When you have square root, remember that's raised to the 1/2 power.
A 1.
That's it, a 1. So that would just be 2 to the 1, right? Or just 1. Okay, so I put 2. Let me just put 1. Because let me just put what I just said. When you have a square root, that's raised to the 1/2 power. So let me just put that over here. Keep that in your memory bank. Okay, square root of 2. Let me put that there. That's equal to 2. And let me just put that is to the 1/2 power. Just remember, square root is raised to the 1/2 power. So 1/2 plus 1/2 is 1. You got it?
Yes.
Okay.
So-
Now, Mercedes, you had a question?
So you're saying the first one right there, that is square root of 2. That's
Times the
1/2.
square root of 2. 2 to the 1/2. 1/2 plus 1/2 will give you 1.
1.
Got it?
Oh, so when we see that this is
Yes. Whenever you see a square root, it's raised to the 1/2 power.
okay.
Okay. Now let's go to outer. Alva, what are the outer terms? Just put outer.
Where we heard, where, okay.
Okay, let's go back up here. What are the outer terms here?
The outer is,
The first was square root of 2, square root of 2.
yes, so we're going
What
to
are the outer terms?
that's the square root of 3. 3.
And what else? Outer, square root of 2 and square root of 3. All right, so let me just copy this. And those are the outer terms. Okay, so let's just put that here. So it would be the square root of 2 times the square root of 3. So let's put the 3
Yes.
here. All right,
Can you please scroll up a little bit, man?
okay.
Thank you.
All right, so that's square root of 2 times square root of 3. Now let's go to the inner. Okay, so inner terms. What are the inner terms, Mercedes?
Is that square root of 3 and
Square root of 2.
2?
Yeah, square root of 3 times the square root of 2, which is really the same as this one, right? It's just the order was a little different, but it's the same. Whether you put the square root of 3 first or whether you put it after the square root of 2, it's still the same. Let's see. So this would then, let me copy this, copy and paste. So those are the same, right? And now let me just put all this on the. Okay, I'm bringing this all over on the next page so you can see it. Okay, so square root of 2 times, now I'm at the L for last. Alva, what are the last terms? Okay.
Last term.
Well, let me just put this here because you don't see it over on this side. Okay, so let me just put what we are using FOIL on. Okay, so what are the last terms, Alba? Look here. This expression, what are the last terms?
The square root of 2.
No, the last square root of 3 and square root of 3. Those are the last terms, right?
Yes,
So let's just copy this and put the square root of 3. Okay, so this would be square root of 3 times the square root of 3, right? Okay, so what's the square root of 3 times the square root of 3? Remember, what did I say about the square root is the number to the 1/2? Mercedes, what would this be equal to?
So square root of 3 will be 1/2, miss.
Square root of 3 times the square root of 3.
Oh, that's what you're saying?
Yeah, follow
Mhm.
just what we did for the first. If
9
square root of 2 times square root of 2 is 2 to the 1, square root of 3 times square root of 3 would be what?
and a
Mercedes?
half. 1.5.
No,
No.
no, 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 no.
Square root of 3 to the square root of 3 would be 2.
That's not it.
3 to the 1/2 times 3 to the 1/2 is 3 to the 1.
Oh, yeah, yeah.
Yeah,
1/2.
just like we did for the 2, except
Oh,
it's a
you
3.
the half with the 3 too, miss? That's what you're saying?
Well,
We
it
use-
doesn't matter. Square root of any number is raised to the 1/2. Except it's a 2 here and it's a 3 here. 3 to the 1/2 times 3 to the 1/2 is 3 to the 1/2 plus 1/2 is 3 to the 1. Mercedes, you following me?
No, miss. When you say the 1/2, I'm thinking of 1/2 is 1 and 1 and 1 is 2. So that is 2. 3 to the
No,
2.
1/2 plus 1/2 is what, Mercedes?
That's 1.
That's right, Albert. Thank you. 1/2 plus 1/2 is 1,
Yes.
right, Mercedes? 1/2, 1/2 adds to 2 halves, and that's just 1.
Oh, I got you. Got you.
Got me? So it doesn't,
Yes, ma'am.
what the
I'm
base
looking at that.
is,
I'm looking at that the other way around, miss. I'm like putting the 2 halves together.
no, it's 1/2, 1/2,
I
2 to
got
the 1/2 plus 1/2 is 2 to the 1.
1.
3 to the 1/2 times 3 to the 1/2, 1/2 plus 1/2, 3 to the 1. Got it?
Like 1 whole, miss. Like 1 whole. Half and
Right,
yeah, I
right.
got
So now we've got everything here. We've got 2 to the 1, 3 to the 1. We have square root of 2 times square root of 3. We have that twice. So we can add those two together. So let's just write what we got from FOIL. We have 2, and I'll put plus 3, right? 2 plus 3, and I have 2 of these, right? So I can write this square root of 2 times square root of 3. Let's put plus, and I have 2 of those, so that's be 2. So we only write what we got from FOIL, right?
Yes.
Okay, so we have 2, we have the 3, and we have 2 times square root of 2 times square root of 3. Now what's 2 plus 3?
That's 5.
5, that's right. Thank you, Albert. Okay, so let me just put here, we have 5, we added the 2 plus the 3. And let me just put 2, I'll just repeat this. Now, if you can factor radicals into 2 radicals, that means you can put them back together, and square root of 2 times square root of 3 becomes square root of 6, right? I'm just
Yes.
putting them back together. So let's just put the 6 here. All right, take out the 3. I'm just multiplying the 3 times the 2, just like we broke up the radicals into 2 radicals. So that's my answer. 5 plus 2 times the square root of 6.
Miss, I don't understand you lay out the answer. I don't
What?
understand. I don't understand how you lay out the answers. You put the 2 plus 3. I don't understand.
Oh, you don't understand how I got 2 plus 3?
Yes, I don't understand you get the, how you lay out the answers.
Oh, you mean the 2 and the 3 here?
Oh, so
I
you
just
take,
took them from FOIL. 2 plus 3. 2 to the 1 is 2. 3 to the 1 is 3. You follow me, Mercedes?
the 2 to the 1 is 2.
It's 2. 3 to the 1 is 3. I have square root of 2 times square root of 3, but I have it twice, so I can add them. That's how I got the 2.
Okay.
The sum of these two, they're the same.
Okay. So you say
So
1 and 1.
2 times square root of 2 times square root of 3, right? But just like we broke up the radicals into 2 radicals, I can multiply these out to get 6, because 2 times 3 is 6. So 5 times square root of 5 plus 2 times square root of 6, which would be answer D. Questions?
Still don't comprehend. I'm sorry.
What is it you don't understand, Mercedes?
You don't get how you, okay. Okay. So 2, first number 2, you said you get it from
The
2 to the
2
1
to the
power.
1, that's the 2, right? From the F first. The
Okay.
last 3 to the 1, that's how I got the 3. These two, let me just take them here. Okay,
Those two are,
these are the same, right? So
so
let
you
me
put
just
2
take,
for that.
yeah, so I had this,
Okay.
let me just put that here.
You
And
don't
if
have to
I,
read.
okay, let
You don't
me just add it. I'm gonna add it, okay. Those are the same. That's how I got 2.
right there. I understood that now. But the
Okay,
other 2, oh, but the for
do you understand how I got 2 times square root 2 times 3? I added these two like set of terms together.
oh, oh,
I added these two together and I got 2 of them because they repeat. They're the same.
so after that now, Miss, after that.
Okay, after this now, remember back up here when we took the radicals and we broke them down into 2 like here?
Yes.
I can also multiply these and go back to what just 1 would be, which is what I did here. Right? Square root of 2 times square root of 3 is square root of 6. Just like you break up the square root of 6 and the square root of 2 is square root of 3, you can multiply them and get square root of 6.
Oh,
You got it?
so that's, oh, you get what?
That's how I
Oh,
got square root of 6.
okay. So I saw it
I
now.
went the other way. Like I could say square root of 6 is square root of 2 times square root of 3. Square root of 2 times square root of 3 is 2 times 3, or radical square root of 6. Got it?
Okay, okay.
So you can go both ways. You could take 1 radical, break it up into 2 radicals. You could take 2 radicals, multiply them, get 1 radical. Got
Okay.
it?
Yes, I think so.
Questions?
So that is how you're working out which number?
That was the 11. So that would
Okay.
be the answer
Scroll-
right here. Okay, let's go back. What is the simplified expression of square root of 2 plus square root of 3 squared?
Yes.
So I said square root of 2 plus square root of 3 times itself, that's the square. Multiplied by itself, that's what the square is, right? Just put it right next to each other. You got it, Mercedes?
What I
And-
was making mistake with, I didn't even notice that there was A, B, C, D, so you choose an answer.
Oh, you didn't see the answer, the choices? Well, they gave you the choice of the answers. So you just take your FOIL and work it out and you'll get the answer D.
Okay, got you.
Any questions?
I need to
Okay,
be more,
all
Oh.
right.
not now.
Maureen asked me about putting something in because she has difficulty doing the square roots and the radicals. I'll try to get the homework mailed to you so you can really do it on your sheet. But if you don't get it, you can just say SQRT.
You mean like the one
The
that we
square
don't
root.
get?
Yeah, yeah,
Okay.
like, okay, you have 6.
Figure it out, Miss Barbara.
Question, Maureen?
Let's figure it out.
Okay, you figured it out. Okay, but
Yeah.
if you having a problem trying to send it to me and you don't have these powers, square root. This is, I'm sorry, this is not. In other words, you don't have the radical. Okay, let's put here. So if you have a problem getting the radical, just use square root
Yeah, root,
and just say that's equal to the radical. All right.
okay.
So if you have a problem getting that symbol, just say square root. Question?
Square RT equal.
Yeah,
Square
SQRT.
RT.
So you can just say square root. So instead of saying square root of, so if you can't say this, let's just put it what I'm saying here. Okay. There's a 2. You can't say that. Just say, I'm just saying this would be equal to square root and then followed by the 2.
Okay.
All right. So those are equivalents. So if you can't get the square root symbol, just say square root 2. Got it?
So Miss
Okay.
Barbara, by
Yes.
the calculator, up top the square root, let's take like a V backward. What is that?
Yes, you're right. On the
I got the
yes.
square root, and then I got
Yeah,
up
it's
top,
it's
right,
on
it's
your
upside
yeah,
down. Yeah, then I got upside down, so I'm doing like a V.
yeah, okay. But I'm saying I'm giving you alternatives. If you
Okay,
can't get
okay,
the
alright.
square root symbol, just say square root. And then
Okay.
for the square, like if you had you could just say you could just use SQ.
Okay.
That would be square.
Okay.
So if you had 6, and we'll put a square on that. Okay, so that would be the same as if you said 6 SQ. Got it? So I'm giving you choices if you have any problem trying to get those exponents in. Okay, a 6 square. And then if it's a cube, you just use CU. Okay, so this is all right. So you can use the SQ for the square, and if it's cube, use just CU for cube. It's raised to the 3rd power. Okay. All right. So and then that will but I'll try to get when I mailed homework for you, Mercedes and Maureen.
Okay.
And hopefully you get it and you could just do it on your sheet. And Maureen, you could have someone in your house show you how to take a picture of it. So once you put your answers, just take a picture and then send me that. All right.
Does the picture go to your gallery and you take it from a gallery and send it?
No, it doesn't. It goes to my files. I mean, I can actually, once you send it to me, I can put it on my
No,
files
telling
and
her
I can
to-
email it to myself.
I'm telling her when she took a picture, that picture gonna go to her gallery. She go in her gallery, and certain things she touch and show you how to send it to you. So I think the younger one will show her to do it.
Okay. Well, I'm saying she's got grandchildren in the house who can show her how to do it.
Yeah.
Any questions on anything we went over? Now, we just went over the homework and we didn't get into our lesson for today. What actually was going to do some more graphs and some more exponents and radicals. But your homework, I think I gave you homework on just, let's see, I have it here. I'm giving you homework, and I think that was on just exponents and radicals. All right. So your
So,
homework for Thursday is just on radicals and exponents,
okay.
especially that the properties I gave you. All right, I'm giving you some on the properties. Okay, so you got the properties. Well, when I send you your session, you'll have those properties. Okay, so make sure you understand those, because I'll give you some samples for you to give me back property it's referring to. Okay,
Okay.
any questions on anything we've gone over?
Well, I'll try to work on it, Miss Barbara.
All right. Well, well, that's all I can ask of you to try. And
Yeah.
so you send me whatever homework you can do, and I just grade you, based on what you did, not the ones that you may not have done, because we'll go over them in class. All right. But at least you should try them. Okay. Maureen, you owe me homework from before, but that's okay. Just make sure you send me the one before Thursday, okay? Maureen? Maureen, I can't hear you.
Which one?
I said the one that I will send you today, due for
Uh-huh.
Thursday. Make sure you do
Uh-huh.
that one. You don't
Ah,
you don't
yeah,
have
good,
to
yeah.
you don't have to. You promised to send me something before 12 today, right? Was that the
Yeah, that was,
college prep?
yeah, but I didn't get to it so much, yeah.
Okay, well, we'll go over it in class. Don't worry about it.
I was looking for this paper like you may left it here. I come back again for my when in my
Okay.
room, my room and destroy my paper like to get my hand the thing by my hand.
Yeah.
Yeah, and sometimes
Well,
it hurt me so bad.
yeah, well, do the best you can, Maureen. I understand you going through your therapy for your
Yeah,
hands, so
yeah.
don't strain yourself too much. We'll go over it. You can just
No,
answer
yeah.
me. You can just answer the questions for me in class, okay?
Hi,
All right.
Maureen.
All right, so I'm gonna say so long to everybody.
Okay, Miss Barbara, have a nice
Barbara.
Okay,
evening. Yeah.
okay.
Coming back 4:30.
Yes, we'll be back.
Thank you.
Excuse me?
We'll be back for the college prep 4:30.
Oh, okay, for this evening.
Yes,
Yeah.
yes. All right,
Okay.
so long, everybody.